Hi everyone, today I brought a question where we will discuss about Atwood machine with friction. Now what is Atwood machine? It is something that you study in your class 11 syllabus, right? Where there is a pulley and there is a string or a rope that passes over the pulley and two blocks are attached to the two ends of the rope. You have to find the acceleration of the two blocks. Now, when you do this problem in your syllabus, you assume that this pulley is frictionless. Frictionless. Also, you assume it is massless. Today, I want to talk about why it should be frictionless. Massless, I will take in some other video. It is more easier. Frictionless is the more challenging part. Okay. So, why this pulley should be frictionless? Why? Because between the pulley's surface, this surface of the pulley, and the rope's surface, which is the rope's internal surface, right? So when there is a pulley and a rope in contact, there may be friction, right? So why are we assuming frictionless? And what if there is friction? Then how to solve the problem of finding the acceleration? Now, if the pulley is frictionless, like you assume in your class 11 board syllabus, there how do you solve the problem of finding the acceleration? Very simple. We draw the free body diagram of this block, right? So tension here, weight here, and we draw free body diagram of this block, tension here, weight here, and then we write Newton's law for this block and for this block. Now, if you assume M2 is greater than M1, then this block will accelerate downwards and this block will accelerate upwards. Why acceleration is same in magnitude? Because we assume this string is inextensible. Inextensible means what? If this point falls by 1 millimeter, this point should rise by 1 millimeter. So the displacement of this point and this point should be same in magnitude. So if one is coming down by some displacement, other one should also go up by same value, because this string's length is fixed. So if something's length is fixed, if one end goes by 1 millimeter, other end also should go by 1 millimeter in the direction of the rope or the string, isn't it? So if displacement should be same, then you know displacement is ut plus half at square. And since initially we assume the block starts from rest, so initial velocity is 0. So now if displacement should be same in a given interval of time, then A also should be same. So that's why we have assumed same acceleration, because this length of the string is constant. Now since this is accelerating downwards, then Newton's law for this will be what? Net force will be this minus this. That is the net force. And what is net force? Equals to m into a. So mass is m2, acceleration is a. So this is equation 1, which is Newton's law applied to this block. And if you apply Newton's law for this block has acceleration upward. That means net force should be upward. So this force should be greater than this force. So what will be total force? T minus m1g equals to mass into acceleration. This is equation 2, which is Newton's law applied to the first block. This was for the second block, remember. Now how to solve this two? Add. If you add, minus t and plus t will cancel, and then if you solve for acceleration, you will get this value. So this is how we usually solve this problem of finding the acceleration. Now one thing very important was what? Tension here and here we assume same. Tension in this string and tension in this string we assume same. Is it allowed? Yes, it is allowed for two conditions. First condition, the pulley here should be frictionless. There should be no friction between the pulley and the rope. And second assumption should be the string and the pulley should be massless. So today I am not going to talk about the massless part, that I will take in some other video. If you are interested, let me know. But today I am going to tell you that if there is friction mentioned, then you cannot say the tension here and here are same. So why tensions here and here will not be same if there is friction? Let us try to check. So let us consider this diagram. Here is a pulley, the black color, and there we have attached this string which is shown by the red color. Now the string is making an angle theta in contact with the pulley. Okay, so the angle of contact between the string and the pulley is theta. And the friction coefficient between the pulley and the string is mu. So this time it is not frictionless, remember, there is some friction. So as I told you, tension here and here will not be same. So what will be the relation between the tension that we want to find? So let's say tension here is T1 and tension here is T2. Tension is a pulling force, right? So tension on this string, the pull on the string is T1 and the pull on this string is T2. So we want to find relation between these two tensions, which is at this point and this point. So as you go from here to here, tension will change from T1 to T2. Or if you go from here to here, tension will change from T2 to T1. In this part, there will be no change in tension because here there is no friction, because here this string is not in contact with the pulley. So wherever the string is in contact with pulley, there because of friction, tension will vary as you move along the string. So how to find relation between tension at point A and tension at point B? Let us try to think. Now to find the relation between the tensions at point A and point B, what I will do, I will take a small part of this string as a system. So let me take this part, okay? And this angle subtended is quite small. So let me call this angle as d theta. Quite small angle, okay? So I want to know what will be the free body diagram of this part as a system. So if I call this part as CD, so I have taken CD, which is part of the string or the rope, as my system. Remember, the string is assumed to be massless right now. So if something has no mass, then its weight will be 0, remember. So if I try to draw the free body diagram of this system, then how it will be? Let me zoom this part and show. Okay, zoom for clarity. Otherwise, you will not get clarity. So though this CD part makes a very small angle, let me show for clarity a big part. So this is CD. Okay, I have zoomed it. This is a very small part actually. Okay, so be careful. Now, how to draw free body diagram of this system, which is a small part of the string? Well, to draw free body diagram, you have to search for context, I told, right? So this CD is in contact with this part AC and CD is in contact with this part DB, isn't it? So because of the string in contact with this system, there will be a tension force. And tension force, how do we draw? It is always along the string away from the system. So if this is your system, it is a away because it is a pulling force, remember, pulling. So this tension, let me write here as P. Now as you go from here to here, I told tension will vary. Why it will vary? Because of friction here. So tension here, which is again pulling force, is, let's say, bigger than this, T plus dt. Okay, so dt represents the small change in tension when you go from C to D. Remember, CD is a very small part. So when you travel the small part, the tension will also vary by a small amount. That small amount is dt. So dt represents the extra tension when you go from here to here. Now what other force will act? You have to search for contact. So I told you this small part of the string is in contact with the pulley. So there will be a contact force. And what are the contact force? One is perpendicular to the surface, that is called normal force. And one is parallel to the surface, that is called friction force, right? So normal force will act along the radius because this is a circle. So radius will be perpendicular to this part, right? So this is along the radius. So this is your normal force. So here there will be a normal force N. and there will be a frictional force here which will try to keep this rope at rest with respect to pulley. That is the whole job of friction, to keep the relative motion zero. So if one is at rest, it will try to keep other one also at rest. So where will be the friction here? Well, how to find direction of friction? I have told you many times. To find direction of friction, you assume there was no friction and check where the body would slide with respect to the other body. And friction will be opposite to that relative motion. So here also, if there was no friction, then because of more pull here, this rope would go that way. Right? This rope would slide this way if tension here was more than here. Isn't it? So to oppose that, friction should be opposite to this tendency. So this part, this small part is trying to go this way, right? So friction will be this way. So this is your static friction, which will try to keep this part at rest with respect to pulley. So now we have taken the system, we have drawn all the forces. Of course, I did not draw mg because we are assuming this string is massless, right? So mg I have not shown. So these are the forces on this part of the string. After drawing that, what we should do next? We should resolve. We should break the forces into components. So for that, remember, this angle is your d theta. It's a very small angle actually. So therefore, let me now take components of this tension. One component will be here, one component will be here. What I have told you many times, if two lines have angle theta and their perpendicular lines will also have angle theta. Matlab, if 1 and 1 are perpendicular, 2 and 2 are perpendicular, then the angles between them must be same. One easy way to understand is, if this is 30, this is 60, because this whole angle is 90. And if this is 60, this also should be 30, because this is also 90. So these two angles must be same. So remember, this line is perpendicular to this line. Let me try to show this way. This and this are perpendicular. Look very carefully. Similarly, this tangent, which is the direction of this tension, is perpendicular to this radius line. From geometry, you know radius and tangent are perpendicular. Radius and this tangent are perpendicular, right? So this and this are also perpendicular. So whatever is the angle between these two, same angle will be between these two. And this angle will be how much? Half of this angle, which is d theta by 2. So this angle you came to know is d theta by 2. Therefore, now you can easily take components. This component will be t cos d theta by 2, and this component will be t sin d theta by 2. By symmetry, we can do the same thing here. This angle is also d theta by 2, and this angle will be also d theta by 2. So this component will be t plus dt cos d theta by 2, and this will be t plus dt sin d theta by 2. Correct? Now, as long as this friction is static friction, this rope, this part of the rope will be at rest with respect to the pulley. So if the pulley is at rest, this rope also should be at rest. So for no slipping, we know friction here should be static friction, remember. And that static friction plus this component, you can see this force is left side, this is left side. So those two should balance this right side component. So t cos d theta by 2 plus this static friction, right? This is left, so those two will be added. Those two should balance this right side force, which is this one, t plus dt cos d theta by 2. Right? Now, for small angles, you know these angles are very, very small. So, for very small angles, we can show that cos theta or cos angle is approximately 1 and sine angle is approximately angle for very small angles. One easiest way to understand this is the smallest angle is 0, right? So cos 0 is 1, not 0. So when angle is very small, cos theta will be 1. So see, these angles are very small. This value can be taken to be 1. Okay. So now the equation will become T plus Fs is equals to T plus dt. You can see T and T gets cancelled. So your static friction is nothing but difference in tension. So quite interesting to remember. The friction here has to balance the difference in tension between here and here. That is what we learned. Now, when our string is about to slip, okay, so when the string is about to slip, meaning it has not started but it's about to start, then that time the friction here will reach what value? The maximum value. So that maximum static friction has to be balanced by the difference in tension, right? Now what is the formula for this maximum static friction? That we already know. Mu s into normal. Correct? Let us call this equation 1. Now this normal has to balance whom? That normal has to balance the downward force. Which are the downward forces? This and this, remember, right? So the normal force N has to balance the downward force. What are the downward forces? T sine d theta by 2 plus this downward force is T plus dt sine d theta by 2. Now I have already told you that when angles are small, like here, sine of angle is same as angle itself. Okay. If you want to see a proof of this, please let me know in the comment. I have a nice proof of this. My students already know, those whom I teach. But if others wants to know how this is coming, please let me know. Okay. So this n will be equals to now t. Sine of angle will be angle itself, I told, plus t plus dt, and sine of angle will be angle itself. Isn't it? Now this diagram we don't need. Let me remove it. So from here you will get n equals to t d theta by 2 plus t d theta by 2 will be 2 into t d theta by 2 plus, so this multiplication I did, right? T d theta by 2 plus t d theta by 2. If you add, you will get this. Then there is dt into d theta by 2. Now whenever you have product of two differentials, remember dx or dy in calculus represents a very, very small change. Dx or dy represents a very, very small change. So if you have product of two small quantities, that product will be very, very small, isn't it? 0.001 into 0.001 will be 10 to the power minus 6, much, much smaller, right? So product of two differentials can be always neglected in comparison to this value. Okay. So once you neglect this, what will be the normal force? T into d theta. Isn't it? This is your equation 2. So if I put this equation 2 in equation 1, what will I get? So putting 2 in 1, I will get mu s into normal is t into d theta is equals to dt. So this gives you a differential equation. And how to solve differential equation? First you cross multiply in such a way that you separate the variables. So let me keep tension this side. dt by t is equals to mu s into d theta. So I hope all of you understood this t I took here. After separating the variables, we have to do integration. All these things we already learned in class 11 when we derive those equations of motion, right? V equal to U plus AT, S equal to UT plus half AT square using calculus method. We do the same thing. First we separate the variables, then we do integration. So let me take integration both sides. Remember mu s is constant, so it comes outside. Now how will we put the lower limit and upper limit? Now remember, I want relation between tension here and tension here, right? So when I am here, tension is T1. So lower limit is T1, and when I reach here, tension is T2. Isn't it? Now when I am here, this angle will be 0. This is my angle theta. That's why this small angle represents d theta. So when I am here, my angle is 0. When I reach here, my angle becomes the total angle theta. So I should have given different symbols, but I hope you understand. So this theta represents the angle subtended by the string, and this theta is the variable. So as you go from this point of the string to this point of the string, your this variable theta starts from 0 up to the final angle theta. So your theta starts from 0 to theta. Okay, so this theta represents the final angle subtended by the string at the center, which is in contact with the pulley. Remember, only that angle we are interested, where the string is in contact with the pulley, because there only friction will act. So now this is easy to do, right? Integral of dx by x is log x. So integral of dt by t is log of t base e. Upper limits are t2 and t1. And here integral of d theta will be theta. Upper limit is theta, lower limit is 0. Now put the limits, you will get log of t2 base e minus log of t1 base e. And here if you put upper limit theta, lower limit 0, you will get theta minus 0. Now log a minus log b is log a by b. So this will be log base e t2 by t1 is equals to mu s into theta. So this is the relation between tensions at these 2 points. Of course, we can simplify this further. Now, according to the property of logarithm, if you have e power x equals to y, then log of y base e is x. So, similarly, if log of y is x, then y will be e power x. So, y here means this y, right? t2 by t1. So, t2 by t1 will be equal to e power this x. Okay, this e power x. So, e base here is e. The power x is this x, which is mu s into theta. Please compare this formula with this formula. Okay. So x here is mu s into theta. So power will be mu s into theta. So this is a very, very useful equation. Now please understand one thing, that this whole formula was derived by assuming that if this is the pulley and this is the string, I told tension here is greater than tension here. So T2 is greater than T1. That is what was the assumption. Because I assumed the string wants to go this way. So to oppose that, static friction was this way. What if this T1 was greater? So if T1 was greater than T2, that means if the string wants to go this side, static friction should be that way. So you can again redo the whole calculation, and if you do that, you will get just 1 and 2 we have to interchange, that's it. Then you will get T1 by T2 will be equal to e power mu s theta. So this also try to remember, because we don't know where tension may be more, right? So now let us apply whatever formula we learned in this problem. Very interesting problem. So we have to find the ratio of these masses so that the system is in equilibrium. That means the acceleration of the two blocks is 0. So if you leave them from rest, they will remain at rest because there is no acceleration. So velocity will not change. So if initial velocity is 0, they will continue to be, the velocity will continue to be 0. So basically we want the system to be at rest. Now remember, they have given the friction coefficient as mu. What if there was no friction? If mu was 0, Then you all know from your class 11 syllabus that if you want this system to be at rest, then m1 should be equals to m2. Right? If you remember the formula for acceleration, it was m1 minus m2 if m1 is greater, or m2 minus m1 if m2 is greater, m2 plus m1 into g. So if you want acceleration to be 0, then these two masses should be same, isn't it? So in that case, what will be the ratio m1 by m2? It would be simply 1. So 1 would be the answer. But here, there is friction coefficient mentioned, right? So we cannot say the ratio is equals to 1, remember. So now for equilibrium, net force on the system should be 0, right? So for this system, the tension here should balance the weight. So weight is m1g, tension here is T1. So T1 should balance m1g. Similarly for this block, here tension is T2, weight is m2g. Since acceleration is 0, total force is 0. So this tension should balance this weight. Remember, this T1, T2 should not be same because friction is mentioned. Be very careful. Now, from here to here, if I go, remember in this part tension will be same everywhere because here there is no friction, right? And this string is massless, so tension everywhere here will be same. So up to here tension will be T1. Similarly, up to here tension will be T2. So here tension will be same as everywhere here, T1. And tension here will be same like everywhere here, which is T2. But between this and this, tension will not be same. And what was the relation we found? The relation was, now we don't know which is greater right now. So let me assume if m2 is greater than m1. That means without friction, the system would go this way. Because m2 is greater, I have assumed. So the pulley would go this way. Right? That would mean friction will be this way, remember. So static friction will be this way. In this case. So if m2 is greater than m1, then T2 will be greater than T1. Then what was the formula I told? T2 by T1 is equals to e power mu s into theta. Now theta is the angle of contact between the string and the pulley. So if this was your pulley and this part of the string was in contact, then this was your theta I told, isn't it? This is the string. But if you look carefully our diagram, the string is in contact this way. That means this angle is how much? 180 degree, isn't it? From here to here. This line is now here. This line is this line and this line is this line. So this angle is this angle. So that angle is clearly 180 degree. In this case, in SI units, pi radian. So theta is pi. Now let me say for simplicity, the coefficient of friction is given as 1 by pi. Just for simplicity, they could give other values also. So in that case, what will be T2 by T1? Coefficient of friction is 1 by pi and angle subtended is pi. So this will be basically e power 1, which is E. And E value is 2.7 something. By the way, I have made a video about the story of this E. So I'll share the video where I describe how this E comes in science, okay, in mathematics. So please watch that video. I will share the link in the description. So now what is T2? To keep the system at rest, T2 should be M2G and T1 should be M1G. So that is equals to E. So M2 by M1 should be equals to E. Then the system will be at rest. Now the other possibility is M2 could be less than M1. So now M1 is greater, so the pulley would try to rotate this way. And to oppose this relative motion, friction should be this way. Right? So now if you do the derivation, now remember M1 is greater here. So to balance M1, T1 here should be also greater. So T1 by T2 now will be e power mu s into theta. Value of mu s and theta are same. This is 1 by pi. This is pi. So that will be again E. And what is T1? M1G, T2 M2 G cancels. So M1 by M2 should be E. So M1 by M2 should not become more than E. Then the system will accelerate this way. And here M2 by M1 should not be more than E. Otherwise the system will accelerate this way. Now what should be the ratio of M1 by M2 so that the system is in equilibrium? For second case we got this M1 by M2 equal to E. For first case we got this, right, which can be written M1 by M2 is equals to E power minus 1. Isn't it? 1 by E. So our answer should be something like this. For system to be in equilibrium, meaning for the rope not to slip, it is important that M1 by M2 should not be greater than E. That means it should be less than E. And M2 by M1 should not be greater than E also, I told. Should not be greater than E. Should not be greater than E. In other words, M2 by M1 should be less than E for no acceleration, which if I take, if I cross multiply, it will come M2 should be less than M1E. And if I bring E this side, 1 by E will be less than M1 by M2. That means M1 by M2 should be greater than, right? This should be greater than 1 by E. So these are the range of M1 by M2. So for this range of M1 by M2, our system will be at rest. So now let's say if someone says M2 is 5 kg, then for what values of M1 will the system be at rest? In the case of no friction, M1 should be also 5 kg. But now there are not one answer, there is a range of answers which are possible. So if you see here, if you cross multiply M2, you will get from here M1 should be less than M2 into E, or it should be greater than, cross multiply here also, M2 by E, or just multiply with M2 all the terms. So if you multiply by M2, you will get this. Now M2 is given 5 kg, so that means M1 should be less than 5E, or it should be greater than 5 by E. So now if you want to know the exact value, you know that E value is 2.7. So this value will come equals to 5 into 2.7 will be how much? 5 7s are 35, 5 3 kg, 5 2s are 10, 13.5 kg. And here if you divide 5 by 2.7, then you will get, if it was 2.5, you will get 2. 5 by 2.5 is 2. This is more than 2.5, 2.7. So this will be less than 2. So let's assume this is around approximately 1.8. So what this result basically means is, if you have a pulley where the friction coefficient is 1 by pi and the angle of contact is 180 degree and one block has mass 5 kg, then for the system to be at rest for no acceleration, the other block should have what mass? It should have any mass in this range, because this was derived by assuming the system is at rest. Remember, the system is in equilibrium, isn't it? So if this block is 5 kg, will it be at rest? Yes, because 5 kg is between this range, 1.8 kg and 13.5 kg. So for 5 kg, obviously it will be at rest. What will be friction? Well, because these two are same, even without friction, these two can balance each other here. So even without friction, these two will be at rest. So no friction is required in this particular case. Now, what if this block has mass 10 kg? Will our system be at rest? Well, yes, because 10 kg is also in this range only, right? So even now the system will be at rest. But now we will need friction, because without friction, because this is more than this, if friction is not there, the rope would slip this way, isn't it? So to oppose that, friction should be this way in this small part. Or in this part, if you ask, it will be this way, isn't it? In this part, it will be this way. So friction will be that way to oppose the slipping. What if this was 2 kg? Will the system be at rest? Yes, because 2 kg is between 1.8 and 13.5 kg. But the difference will be now, without friction, what will happen? Because this block has more mass than this, if friction was not there, because tension here will be more, the system will rotate this way. So the rope would slip this way. So to oppose that, friction should be this way. Okay. So this would be the direction of friction. So friction is very interesting. Okay. It is not always in one direction. It will see where the body wants to sleep. If you want to sleep here, friction will be here. If you want to sleep here, friction will be there. It's not like gravity, which is always downwards. Now what if this was 15 kg? Now will the system be at rest? No, because 15 kg is outside this range. So now the system will accelerate this way. Okay, so this block will accelerate downwards. This block will accelerate upwards. You can find the acceleration using Newton's law. You can give a try. If you want me to do that part also, let me know in the comment section. Now what if this is 1 kg? Will the system be at rest? No, because this 1 kg is outside this range. Right? So our system will 100% accelerate. Now how it will accelerate? This way. Okay. And you can again try to find the acceleration.